thanks, Dalita, for the introduction, and thank you for the Division of Research Development for hosting the series. I think it's really exciting, and I'm very honored and feel very glad to be here today, also in this beautiful venue. My friends and colleagues will know that a huge passion of me is this notion of trying to link art-science practices, trying to see how art and science can start influencing one another, and I'm always the weird one looking for museums and interesting places to link science and art initiatives together with. So for me, this is a very special venue. I feel quite at home here. Thank you very much for that. So the talk today will be on, the title I gave it is Rehumanizing Complexity. And I think that is probably even more complex than just thinking about complexity. And if people sort of, come to us in the street or where we have host things, people always ask us, so what is your center also has a complex name. What is it that you do? And instead of just throwing our hands up in the air, I'll try today to put the work that we do and our special brand or our special engagement with complexity in a little bit more context in relation to what's happening in the world, but also how we see it and what the value and also the impact is that we can have from this perspective in Africa. So I'll start with a quote I found on the website of the University of Amsterdam's Institute for Advanced Studies, which has a very special focus on complexity. And I think this sort of sets the scene for most of the work that's being done on complexity in universities at the moment. So I'll just start the quote where they say, we live in a world where everything seems to be interwoven with everything else, and where cause and effect are hard to unravel. Understanding what kind of interventions will produce what type of outcome is one of the most urgent and challenging questions of our time. At the IIS, researchers from a wide range of fields work together on complex scientific and social challenges, and the question unifying them all, one ring to bind them all, is, can complex adaptive systems be controlled? So I think the challenge that we see today and that research institutions and organizations are facing is really this challenge of complexity, and how do we actually respond to this challenge? Not by just saying that things are complex, but that we actually in a time now we have to urgently respond. When we start looking at the literature that speaks about complexity and we start Googling and we start engaging with this idea, we see that there's a kind of a general acknowledgement running through all this literature that tell us that the engagement or an understanding of complexity introduces a kind of a paradigm shift from classical Newtonian worldviews. So there's this impetus and this idea that in order to engage with complexity, we need a new kind of a thinking, or we need a new kind of methodology, or new kinds of models, methods, frames to understand complexity. So this notion of the shift is quite apparent. And the shift, they usually say, is to include a kind of a relational worldview that recognizes the dynamic interactions between the interconnected parts, which result in emerging or emergent systemic properties. And these properties can actually maintain themselves in patterns over time. So there's, and I will try and unpack this a little bit more because it's quite technical. Basically what it means is that we change the assumptions of how we see the nature of the world. So science from the last 200 to 300 years, or the scientific frameworks or principles that informed our assumptions of the world, assumed that the nature of the world is orderly, it's in stasis, in other words, kind of a closed system, it's pure and it's knowable through the study of well-defined problems. Whereas the understanding of complexity opens up, challenges those assumptions in a way, and brings home this idea that the world is actually constituted by contingency. Things change all the time. It's contextual. Indeterminacy, systems in non-equilibrium, meaning that they're open and that they're process-orientated, and that they're only knowable through sense-making and exploring its messy organic vitality. That's really what that technical terms mean, to say, well, how do we shift from a kind of a machine thinking view to a kind of a living systems view of the world? What is complexity science? So there's a kind of a new upsurge in these ideas and these theories on complexity. A basic definition could be to say that it's an investigation into the emergent order of the phenomena in the world that we cannot explain by reducing everything to sort of elementary particles or building blocks. So this idea that the nature of reality also exists of nicely constituted building blocks or particles that sort of constitute each other, also sort of, in a sense, I wouldn't say falls apart, but becomes quite limited if you want to understand living systems, for example. So there's a shift to studying processes, modes of organization, and the causal relations that form what they call the recursive patterns and sort of understanding of how they come about. So to sort of radicalize that idea, there's a quantum physicist, the Italian quantum physicist called Carlos Ravelli. He just brought out a new book on sort of the nature of time, where he says when we reach the sort of quantum level, it's the shift that you have to make in your mind to understand what the nature of reality is about, is almost understanding that there's a shift from thinking that the nature of reality is made from stones, rather to think that it's made from kisses. Sort of this. So there's a kind of a shift to say, well, kisses are like events that come about when people engage and meet. It's not something, but they form a kind of invisible structure that keep people and things together. So how do we start thinking, not in terms of units that we can easily disintegrate and unpack, but rather to try and think about what are the forces, the relations and the interactions and the organizational patterns that keep things in the way that they are. So I won't go into the quantum level because I'm not an expert there, but we always try and think of sort of analogies and reasons to explain this shift that's happening in thinking. It probably also only be an Italian physicist that can come up with an analogy. What we see is that sort of common to all studies on complexity. There's a very nice basic definition by economist Brian Arthur, who says that complex systems are systems with multiple elements adapting or reacting to the patterns that these elements create. So it's this understanding and that feeling that there are elements in systems, patterns, relations, forces that bring about a certain kind of organizational pattern. These patterns inform each other, and this is what we want to start studying when we start studying complexity. So there are many technical things. Now, we don't have time to go into all the technical things, and I don't really want to bore you with that. I really want to just give you a kind of a sense or a feeling. What is it that we study when we start speaking about complexity? This idea that there's a shift in thinking of the underlying assumptions. What are those assumptions, and what are the things that we are looking at? What we're seeing currently in the world, that there's a kind of a complexity turn. So when my supervisor and mentor and friend Paul Saliers started about thinking about complexity about 20 years ago in the early 90s, he was a bit of an outsider with all the other people that were thinking in the same way. So it was kind of a marginal field of study. I remember he went to conferences where people would put their jackets over their heads. If people started speaking about complexity, they didn't really want to hear about this. But these days it's become kind of mainstream. It doesn't matter where you go. There's a general sort of money throwing at complexity. There's a general kind of a supporting of that, and we'll see just now how it becomes. But it's become quite a mainstream thing, and navigating different understandings of complexity is, I think, becoming quite difficult, and the space is becoming quite crowded. We see that it is a field of study that developed from the natural sciences, engagement in physics or new insights in physics. It's a kind of an after-war science also, after Second World War science. Insights in physics, chemistry, nonlinear mathematics, biology, cybernetics, and the study of turbulence in systems far from equilibrium informed a huge field of the concepts and the ideas and the jargon, the theories that we call complexity theory today. This map that you see there tries to sort of map out the starting points, starting from the left round about in the 1950s. And it shows you that this field already is a kind of a hybrid field in itself. People steal ideas and concepts from different fields of study, and then they import it in their understanding of where they're going. And it reaches out to from big data science, computer science, economics, philosophy, and these field of study as such is not the neatly bounded study that you can say, okay, that is what complexity science is about. We see a huge explosion in publications of complexity, podcasts and multimedia websites. Today there's a huge body of literature on complexity. And we see that these ideas that inform the knowledge frontiers in the natural sciences are now being translated and implanted, and it's migrated to inform new ideas in the social sciences, humanities, management sciences, even consultancies. And not only is it staying in academia, it's actually migrating and infecting other social domains as well. So we see centers or publications or ideas popping up in fields like monitoring and evaluation practice, policy making, strategic thinking, national and global governance, and then sustainable development challenges as well. So these things are also sort of really, the ideas of complexity are really bridging and crossing the theory practice domains quite rapidly at the moment. And this is resulting in a kind of a huge development of what we call complexity centers in the world. The most famous being the Santa Fe Institute, which started in the 1980s in the United States. They started out as a kind of a computational center for computational complexity and modeling economic models. But these days they're also bridging those gaps from and also sort of doing research on biological complexity, social complexity, including art and literature and everything into their work. They're still sort of, I would say, kind of one of the leading institutes in the world doing work on complexity. Then we see also in Asia, sort of the Nanyang Technological University is probably also becoming a huge hub in the East. And they're engaging complexity with sort of foundational concepts, health sciences, studying cities, which is in Asia a huge growth factor at the moment. And they're drawing important scientists to that part of the world. They're also hosting the next conference this year, which I'll be happy to go and attend and to see what they are doing there. But they're becoming a major hub at the moment as well. And then in Europe, the biggest hub, the new kid on the block, is the Vienna, the Complexity Science Vienna hub. They have strange-looking guy in the middle, Stefan Thurner, physicist and mathematician. He's like the new whiz kid. He's got more than 200 publications on complexity, but it's all, in a sense, what we call quantitative complexity. So using big data sets to study, and linking them and looking at sort of multi-scale networks and cross-scale interactions and bringing those things together. And they have huge funding. They're just funding 5 new posts for 5 years, just doing research, no students. And they're becoming a huge, attractor for complexity science in Europe at the moment. And then there's also what we call these slick consultancies, people that are, becoming consultants and informing business practices with complexity models or applied understandings of complexity. And these are huge sort of money spinners in Europe. We'll be going to a conference in London later this month to engage with them with these kinds of consultancies again, to try and see what they are doing and what they are bringing about. Slick-looking people, movers and shakers, putting McKinsey, and they are small, what they call boutique consultancies, and they are much more flexible than people like McKinsey, because they can sort of hit and run, but they can also tailor-make and be quite contextual, and they come in with really neat kind of toolkits that can, that's easy, that can easy change. So that's just a little bit of an overview of, what the hype is about. For newcomers who want to come into this field of trying to understand complexity, it could be quite overwhelming. And we see that different fields of study and approach inform different approaches on this understanding of complexity. And what you see in the world at the moment is there are 2 very sort of distinct approaches for understanding and engaging with complexity. So the highway at the moment is what they call computational complexity. And these are the big centers that sort of collaborate with big data engagements, where they try and engage or understand the scientific foundations, sort of, I would say, use sort of natural science approaches to quantify complexity. So they use that capacity to sort of observe and analyze and quantify behavior, connections and structures, phases of complex systems. by means of mathematical equations, algorithms, and computational models. So there's a huge expansion today there. And a lot of energy and money is going into those fields. And then I would say there's the field of what I would call critical complexity, which is probably the field of complexity that our center or that we are engaging with, that we are famous for, I would say, in this field or in this sort of landscape of this ecology of complexity thinking, where we try and use or where we're engaging with philosophical and practical engagement of complexity. So what we do is we use those ideas that come from the natural and hard sciences and the assumptions on which those ideas are based, and we try and translate them into so what? What does it mean for us who want to engage and solve complex problems? So, because I think we can do and we can know and find a lot by crunching data, but we don't always have the answers as to why do we get the results that we get. And this is where I think that we can start making a really huge contribution from our side, is to start using different kinds of data, but also to try and provide a space where people can actually practically design interventions where people can use the ideas of complexity. So in a sense, this idea of critical complexity is a critical engagement with complexity and then practices and science that informs it. And in a sense, it's this two-way traffic. It's this going to and fro from the sort of the theory or the science of complexity on the one hand, and the philosophical and ethical questions that these assumptions and theories can answer. So I call it, and this is where the rehumanizing complexity comes in, because if these assumptions and these concepts and these constructs and theories aren't useful for telling us what it means to be human, how we can understand each other, how we can come up with different sort of values and solutions to today's problems, then I think it just remains quite abstract and technical. And I think there's a huge imperative for us to start applying those ideas in these questions of what it means to govern complexity. So this idea of sort of rehumanizing complexity, like I said, is a critical engagement, shifting this idea and enlarging the vocabulary of what it means to live and experience complexity, and how we sort of engage in that. We often say it comes about with a change in attitude. There's a switch from just observing and analyzing and quantifying complexity to understanding the ethical and the experiential parts of what it means to be alive in this world. Who we are as individuals, consumers, producers, organizations, and citizens participating and contributing to a global, increasingly complex and interlinked world. And this participation in the complexity and in the world brings about ethical, moral, and ecological questions into play. How do we create? Algorithms can tell us a lot about the nature of things, but it doesn't tell us how to act. So I've asked that to a big data cruncher recently. Can your algorithm come up with new values for society? Because if it can do that, then I'll start studying code. But until it can't do that, give me, I'll look for other solutions in other places. We do need to merge these ideas, these two worlds of algorithmic thinking and the huge value that we get of being able to have a grasp on big data and the complexity of those data sets. But it means nothing if we don't know how to act differently or how to engage, what are new ethical values and norms that we need actually to engage with this complexity. So exploring questions of value, justice, and meaning, these are the questions concerning our future and the future of mankind, and also the future of our planet. And these are the sort of the deeper understanding of complexity that I think needs to sort of largen the vocabulary of the sort of the computational complexity that's out there in the world. So quickly, how to proceed? How do we do that? For students coming into this, I've showed you that sort of the overview of what the landscape of the complexity is. It's quite a marshland to navigate, and it doesn't matter where you enter into that map, that crazy looking map, you will find a different definition of complexity or jargon and terms and terminology, depending on where you actually land on that map. So what we did recently, and I think this is a nice contribution or impact from our side, is that we did a systematic review of all the definitions, all the characteristics, all the features of complex systems that's out there. And we came up with a list of many of those, and you see that each theorist has their little list of what qualifies something to be complex, and those criteria differ from who the person is talking about it. So how do we actually find a middle way just to tell new students or practitioners this is what the nature of the beast is about? So what we did is we sat back, and probably it can only be a mom with a 9-year-old son that has to pack up Lego every night. Found a way, tried to make sense of all this stuff lying around, these bits of pieces. Thought, well, if you could have a nice sort of a box that you can put stuff in that are almost similar, you know, we can always play with these concepts a little better. So we came up with what we call a conceptual framework that clusters these different features of complexity in little boxes. We put typical or similar ones together, cluster them together, and then we give them a name. It's almost like marking that little box with a name. We came up with 6 little such boxes. They're sort of conceptual Tupperware holders with which we can put in all these little names or the jargon that inform complexity theory. This conceptual typology offers some orientation to facilitate reflection, and from this sort of more ordered, or I would say from having these different boxes or labels, we can actually start unpacking what those very technical and abstract names and features of complexity mean practically. So that's a kind of I would say a magical thing that we managed to do. So I won't go into all of them today because they you need more time to sort of engage with that. But I thought it would just be interesting for you to show you what we did, and I think within the field of complexity thinking and complexity science, this will become quite a nice and useful paper. It came out last year. So we distinguished 6 categories. The first one, they're structured into sort of the structure of such systems, and the other one in the processes. And what you can see is on the left-hand side, you see we have a little box where we qualify what they are. Then we put into this all the similar features. Then we say, what are the implications for studying such systems? And then what practical methods, be they scientific methods or practical intervention methods, we can use to actually study those features. I'll just quickly go through them. The first one is we say that all complex systems are constituted relationally. It means that behavior emerges as a result of these sort of recursive and aggregated patterns of relations that exist between the components. The features through which you can actually spot that and recognize that and observe them is if you look like net-like structures, hierarchies, and different ways in which things are connected to each other. And the practical implications for that, for example, is that if you want to study relations, we need methods like net mapping or sort of networking models or agent-based models to start actually exposing the relations that make things what they are. We need collaborative processes, and we need sort of ways to be able to unpack those relationships. The second one, we say that all complex systems are radically open, meaning that they are systems not in equilibrium. There's a movement of matter, energy, information coming from the system and the environment. How do we start seeing those systems not as closed systems, but as embedded systems, living systems? In a sense, you can almost think about the immune system as such a radical open system. It's something that comes about because it's not something you can cut out and see under a microscope, but it's something that is real, and it comes about because of its sort of embeddedness in these systems. And if you understand that systems are quite radically open, we can start thinking about sort of the different kinds of scales and interactions that happen across scales. And when we start thinking that something that always we thought that something that just has sort of a local local sort of event doesn't have global impacts, we see now that many local events start having global impacts. And global impacts, once again, have sort of local causes in their field. So how do we start, that is sort of the implication of start doing that, and how do we develop methods to actually studying those cross-scale methods? We see that all complex systems are sort of context dependent. The nature of the system actually comes about because of its the context in which it is. And if you change the context, the nature of that system will change. So how do we start thinking about the fact that contexts give people certain kinds of identities or certain kind of features? For example, in this context, I'm a researcher and I do my thing here, but at the same time, actually just now, I'm also a mom, which is a different context. My son's having his little tuck shop sale now. It was planned in the beginning of the year. Luckily, I could, ask my husband to jump in, and he did his academic year there at the medical faculty, threw it out, and he's selling the stuff at the tuck shop now. But it means that our context defines, in a sense, who we are. And different context gives us different identities, roles, or functions. How do we factor that into our models and our understanding of complex systems? They are adaptive. We spoke about that earlier on, but they are sort of radically adaptive to the sense that they are resilient, and they have tipping points. There's memory in the system that they can learn and they can self-organize. And we have to have sort of our practical methods and methodologies actually have to take that into consideration. They're dynamic, which means that they have these nonlinear interactions, which can sort of be dampened or inhibited. So small things can cause large effects, and we have to start thinking about the effects of these dynamic interactions. And last but not least, we say that they come about through complex causal mechanisms, which are multiple interconnected causal mechanisms that are synergistic in nature, resulting in sort of what we call systemic emergence. So it means that we have emergent phenomena that we cannot trace back to sort of initial causes. So this idea of a kind of a root cause falls away when we start thinking about complex phenomena. How do we start studying causes and effects that we cannot really trace back to some root cause or to some kind of a linear unfolding of a pathway? So this is just sort of it's not important, I think, that you go through and understand these principles, but these principles unpacked in this way, linked to the features that we see in the literature, opens up the door for us to start thinking, what do these mean practically for designing interventions that can address the governance of complexity? So we see, if we want to start answering these questions, a kind of a normative element creeps into this whole idea of complexity, which also our computational friends don't really like always. But living in this world means that we have to make decisions, and we have to actually have some standards or criteria along which to be able to make those decisions. And these criteria also change when we enter a complex space. They aren't clear-cut anymore, objective, freestanding. These criteria actually become part of the system in a sense. They're drawn into the context. So we see that meaning, truth, and norms are no more absolute than the networks and the relations that they arise from and that they reflect. It doesn't mean that they are arbitrary, but they are real, but they are relationally constituted. So this idea of norms that are relationally constituted, quite a new idea. How do we think of norms as not something that, falls out of the sky and is untouched, but something that actually is an effect or a result from the system from which they emerge. It means that each community or network has their values and behaviors that are valid within that network, but they could also be destructive of those communities. So we see in today, the world, the idea of a kind of a radical pluralism, especially in the north, as a kind of a result of how these internal values start conflicting with each other as well. If we start understanding that norms are made for the system, or not made sort of for the system, but with the system, in partnership with the diversity in the context, we will engage differently in the ways in which we start making norms and start making decisions. Understanding that we cannot just, copy and paste things that is valid from one context to another becomes quite important, and it means getting our hands dirty, understanding the context, getting people's buy-in, and understanding the contingencies of the context. What does this mean for us when we want to study complexity? It means that we have to shift our focus from looking at things as if they were machines, but rather to understand them and engage with them as living systems. Natural and social systems cannot be studied as if they were complex machines. Another Italian colleague of ours and fellow here at STIA says we call that a category mistake when people do that. We get wrong information and wrong outcomes. We have to start looking for the dynamic patterns of organizations. How do we see the connections that make things that they are in organizations? It's very difficult to put organizational relations under a microscope or find indicators that can actually qualify what relationships are. How do we measure friendship, love, trust? What indicators do we use for those kinds of things? When we speak to our stakeholders in decision-making capacities, they often say trust is the most important thing that we want to have in our relationships here. We have to shift our understanding from studying characteristics of parts to characteristics of systems. How do we keep those systems together? And how do we sort of engage? What methods and models can we use to start studying systemic properties? And we have to shift our understanding from studied closed systems to open systems, thinking that this idea that problems are neatly contained in a kind of a fishbowl mentality, or that we can actually then zoom our interventions, into sort of neatly under the idea that problems are, contained, and if we target them nicely with strategic interventions, they would be solved, is a misunderstanding of this notion of complexity. We have to actually see things in the context and let them loose to understand how they work. From measuring to mapping, meaning that how do we start understanding the relationships and the sort of the landscape in which these systems happen? And then from objective knowledge to sort of and the sort of objective observation of those knowledge systems to a kind of a subjective reflective awareness and participation in those systems to understand how we can actually engage. Okay, a lot said. How do we do this? And I think this is the big challenge, and I think this is where I hope to also show that this is really what we try and do at the Center for Complex Systems in Transition. We try and engage with those ideas, and we try and develop ways in which we can actually bring together disciplines, methods, themes in a way that embraces what we call complexity thinking, that allows us to use sort of these principles of complex systems and the assumptions to think about things like sustainability science and use interdisciplinary and transdisciplinary research methods to get our hands dirty. It's a kind of a collaborative research in teams with expertise from different disciplines as well as from policy and practice, societal stakeholders. And it's stepping into a role where we become an interface, actually, a knowledge partner between theory and practice, and sort of embrace these different kinds of things. We're able to operate in such a way. We often host what we call facilitated dialogues in order to get the multiple perspectives that people come from before we can come up with solutions. We do learning journeys. We go and sit in the spaces where solutions have to be found. We do scenario visioning. We try and think radically differently about the future in different creative ways. We do regional capacity building. We embrace action research, which has an array of many other kinds of methodologies. And we do publications and sort of try and engage sort of also in media. We have on our website, if you click on the website, you'll see there's a lot of sort of interactive things that we try and do, like MOOCs, executive training, even winter schools, videos, interviews, T-labs, art science engagements, to try and embrace this messy vitality that we have when we engage with complexity. And then we get into trouble by collaborating across a broad spectrum of ideas when we start engaging with complexity. So I've recently been collaborating with some geophysicists on geoethics, because even geophysicists who study volcanoes and measure atmospheric things are understanding that we can have all these data points, but if we don't know how to make decisions with all the data that we have, it doesn't mean anything. So I was recently at this geoethics conference in Vienna, where 16,000 geophysicists came together and wanted to speak about how do we actually change the world. We do different kinds of things, looking at how human nature interactions can be redefined by looking at these interconnections. Okay, the way forward. Where do we go from here? What is the contribution that we, as a center, or the complexity thinking can give us in the way that we have done? I think definitely putting Africa on the map is one of the most important things that we can do for the work that we do in Africa. Worldwide, this little complexity hub that we have here in Stellenbosch is the only hub in Africa that is doing research on complexity. There's no other place. There's not even a network modeling kind of a hub in Africa. So how do we use also this experience that we've gathered in the last 10 to 12 years on doing work that's very contextual to ours, from where we are, and showcasing that a little bit to the world and informing different understanding of complexity. So there are some opportunities. Managed to get the Society for Systems, International Society for System Sciences to be hosted in Stellenbosch at STIAS next year. This is a society that's 66 years old. It's the beginning of the Macy conferences, the Gregory Batesons, von Bertel Landfries, those guys started this organization in America just after the war. It's never been to Africa. And I twisted their arms and said, we can host this. And they're coming here. I'm very excited to do that. It will also be in conjunction with the INCORSI, the sort of the systems engineering conference that will also be hosted here. So we hope to showcase and expose African scholars to systems thinking that next year, and the world to what's happening in Africa. And then we've also been invited to submit a UNESCO chair in complexity and anticipation with my colleague Tanya Hishet, who's a strategic foresight practitioner, works with anticipation, and we'll host this chair here as from next year. There are many challenges. Try and do things like this. I'm part of a group of young scientists that are from sort of complexity hubs around the world, and we'll meet together next month again to try and say, what are the challenges that centers like what we are doing, interdisciplinary centers that are trying to do different things, what are the challenges that we face? And these are some of the quotes of my colleagues. In current institutions, disciplinary divisions and the role of research and innovation are still framed within mechanistic frameworks, they say. It creates a rigid ways of thinking that favors separation rather than integration. But then there's always this double bind between finding simple solutions to tame complex situations. And then institutional design, of course, might easily fall into the trap of sort of a purpose and impact-oriented practice. So how do we give space to something that is quite experimental and collaborative, where mutual learning has to take place, and rethink ideas of how to sort of manage or chart impact and also outcome in a sense. We need new ways to do that. We have to sort of create different kinds of incentives for researchers to benefit from this sort of inter and transdisciplinary designs. Often we see that notions of complexity or systems thinking, it's a little bit like a square peg in a round hole. In many institutions overseas, they are either located in business schools, where they become sort of think tanks for business solutions, or they are situated in sort of physics labs somewhere in a corner. Where do we put people that study complexity? I don't know. Luckily, we have a dedicated space with institutional vision at Stellenbosch that we have a space here for which we are very thankful. And people in the world are also looking at us and saying, "Wow, how did you manage to get that right?" there are some wizards here in the room that manage to get these things right. Huge challenge is also research funding and professional recognition, and then also how research initiatives are sort of judged. We also see that supervising students that come from various backgrounds and are also challenged to find their way in this new space of navigating, studying systems and trying to understand complexity. But there's hope, and my final reflections, and I'm almost done, is that I think talking and teaching about complexity could help to create new formats and spaces of dialogue and collaboration, where we can actually design different ways in which people can think differently and see themselves as people who are actually who they are as researchers, or the other kinds of roles that they take on in this world, that we see that we're all facing societal challenges and we all need complexity thinking to step out into the world today. We have to understand that ethical considerations are always attached to understanding complexity, and they derive from this really foundational assumption of this notion of interdependence. And how do we start thinking of interdependence actually as a kind of if you want to explain complexity to your cat or your dog, just start thinking interdependence. How are we connected to things in ways that we don't even know? I recently had a wonderful experience where I had to also speak with what do they call them, a planetary physicist or interplanetary biologist. It's someone that looks for life on different planets. And he wrote a book called Earth in Human Hands. And in this book, he explains that the bone in our bodies are actually sediments of stone that sedimented that is sort of formed in organisms over millions of years. So once we start thinking that, the bones in our bodies are connected to the stone that sits here in some way, these are the kind of interconnectedness that I'm speaking about. How do we start thinking about connections in such a way that really tries to expose and our thinking to the nature of how we are interconnected? My last slide, and I will finish with this. By recognizing that we are being in and of this world, while shaping the conditions and possibilities for world making, we are called to remember that we require each other in unexpected, real, and imaginary collaborations that are realized by being deeply aware that we become with each other or not. And this is the heart and the core of complexity for me, is to start seeing how can we start looking at the connections and the interdependencies that shape us, who we are, and what are those interdependencies and connections that help us shape the world back again, so that we can actually step out and start engaging with the problems that we face every day that are interconnected and complex in new and creative ways. Thank you very much.